Hello students, this is lecture 3, lecture number 3 of chapter 1, that is electrostat. In last lecture we have discussed about the charging by friction and charging by induction. Today in this lecture we will discuss about the charging by, it was the third point, charging by conduction. It requires physical contact. Suppose you have a body which is not charged initially, that is the neutral body. Again, I'm telling you what the meaning of neutral body. It is the body having equal amount of positive and negative charges. This is the neutral body. Now, you are having this neutral body and another body, this neutral body, suppose the charge 5 Coulomb. This Coulomb is the SI unit of charge. It is Coulomb. Okay. In short, we write here with the capital letter C. Actually, this Coulomb is very big unit of charge. So we use this unit with mathematical suffix like millicoulomb, 10 to the power minus 3 coulomb, microcoulomb, 10 to the power minus 6 coulomb, nanocoulomb, 10 to the power minus 9 coulomb, picocoulomb, 10 to the power minus 12 coulomb, femtocoulomb, 10 to the power minus 15, and so on. So this is a big unit of charge we use as coulomb, and we use mathematical suffixes to represent charge in small amount. Now students, suppose you are having a positive 5 coulomb charge body and this is neutral body. This one, this is neutral body. If you make a contact this body, say A and B, with this body, then what will happen? This is the initial condition. So the final condition will be, after contact and separation, you make contact and separate this body A and this body B. What will happen? First, this two body will have the total charge. How much the total charge will be? QA, it was 0, and QB, it was 5 coulomb. What will be the total charge? It is QA plus QB, total 5 coulomb. And now the charge will distributed equally. Remember students, actually the distribution of charge depend upon the shape and size of the body also. We are discussing here if the both the body are identical. So let me draw this body as it is of the same dimension as A. This was the neutral body. Body A and B are of same dimension. In detail we will discuss in next chapter what will be the charge distribution if the body have the different dimension. So both the body have the same dimension of radius r. Now the total charge is 5 coulomb, and this 5 coulomb will equally distributed on both the body A and B. So it will have 5 by 2 coulomb positive and 5 by 2 coulomb positive. In this way, the charge will distribute for few seconds pause your video and try to solve this question. The question is, if you are having two body A and body B. This body A having minus 3 Coulomb and this body B have plus 9 Coulomb. Initially, after making contact with this body B, what will be the final charge on body A and B? Try to solve by yourself. I hope students you have been solved correctly. Now this body A and B, the total charge QA plus QB will be minus 3 Coulomb plus 9 Coulomb. How much it is? 6 Coulomb. Now this 6 Coulomb will equally divided in both the body A and B, that is 6 by 2, and this is the positive, so the plus 3 Coulomb and plus 3 Coulomb. Hope you enjoy this example. It's very easy. Now the next example, try to solve. You are having three bodies A, B and C, identical. Remember, all the three bodies are identical, A, B and C. And listen carefully this question. This body A have 2 Coulomb, positive 2 Coulomb. This is neutral body, and this body have 6 Coulomb. You have to bring this body A and make contact with body B. Which one is going? A is going to make contact with B. Now B is here only. Again this A, remove the contact with B and bring to make contact with C. Which one is coming? Again A is coming to make contact with C. And finally all three bodies are separated, A, B and C. So the question is, you have to find the final charge on all the bodies A, B and C. This is body C. So pause your video and try to find out the answer. What will be the answer? Okay students, let me solve this question. So A were made contact with B. So the total charge of A and B, it is 2 Coulomb plus it was neutral, so it is 2 Coulomb only. Now arrange A and B. A having 2 by 1, that is a 1 Coulomb positive, and B having 1 Coulomb positive. Okay. Now B itself is here only. Again A is to bring and make contact with C. Initially when A bring to make contact with C, it has 1 Coulomb and this body C have 6 Coulomb. So the total charge QA plus QC, 1 plus 6 Coulomb. How much it is? 7 Coulomb. Since equally charge will divide on both A and C. So how much it is? 7 by 2, 3.5 and 3.5 Coulomb. Both the positive 3.5 and positive 3.5. So finally you can arrange A, B and C, because later on you will be asked to find the electrostatic force between A, B and C. Try to arrange A, B and C. Finally A having plus 3.5 Coulomb B, because it was made contact once only, so 1 coulomb, and C finally having 3.5 coulomb. This is plus 3.5 coulomb plus 3.5 coulomb. So this is the answer. The final charge on A will be 3.5 coulomb. Final charge on B will be 1 coulomb plus 1 coulomb, and final charge on this body C will be plus 3.5 coulomb. Now students, next topic we will discuss calculation of amount of charge. Suppose students, I am asking a question that find the amount of negative charge in 250 gram of water. That is, probably the 1 cup of water contain 250 gram. It is not a standard data, but you should remember in examination sometime it is asked as in 1 cup of water calculate the total amount of negative charges. So how you will solve this question? Actually, to solve this question you have to use mole concept that you have been studied in chemistry. Mole concept. Before starting solving this question, we should remember the value mole and the number of electron, that is in mole, Avogadro's number, etc. In 1 molecule of water, how many electrons are there? Number of electrons. So it is H2O is the 2 electrons of hydrogen and 8 electrons of oxygen. So we have total 10 electrons in how many molecules? In 1 molecules. We are having 10 electrons in 1 molecule. Now we have to find how many molecules are there in 250 gram of water. So 1 mole of H2O contains how many grams of water? So 2 grams of hydrogen and 16 grams of oxygen. So it is 2 gram plus 16 gram, it is 18 gram of water, 1 mole, and 1 mole it is equivalent to the Avogadro's number. How many molecules? It is the solid, it behaves like solid. 6.022 times 10 to the power 23 molecules. If you are not remember, then you should remember it. This is not very tough question. You have been studied in your standard 11th and I think 9th or 10th also. So 1 mole is equals to this much molecules, and 1 mole equivalent to the 18 gram. It means 18 gram of water is equivalent to the 6.022 10 to the power 23 molecules. molecules, and 1 gram, or directly we can write to not make expand this video, 250 gram of H2O will be equivalent to 6.022 10 to the power 23 over 18 times 250 molecules. Okay, so this much number of molecules. As we have discussed already, one molecule here of H2O contains 10 electrons. Here the one molecule contains 10 electrons. So the number of electrons will be 10 times the total number of molecule. Since one molecule contains 10 electrons, so this much molecule will contain 6.022 10 to the power 23 by 18 times 250 electrons. Hope you are getting. You can pause the video and make calculation. So this will give you the number of N. Now you are having the value of N, but the question was asked, you have to find the amount of negative charge. According to the quantization of charge, Q is N times E. So N you can put from here. It is N times electron, that is the charge of electron, 1.6 times 10 to the power minus 19 Coulomb, and you will get the answer. It is the amount of charge, that is the Q. Later on you will use, the question will be asked, if the total negative and positive charges of 250 gram of water are lumped together and separated by some distance, then find the electrostatic force between these two charges. So in this way you have to find out the number of negative charge and positive charge. Remember, water is electrically neutral. If it is electrically neutral and it has the total number of electron is this much, then it is having the total number of proton also. So the same number of electron and proton. So you can find the electrostatic force between these two charges, students. Here I am leaving you a question as assignment, home assignment. You have to find the number of protons in 10 gram of copper. Okay, find the number of protons in 10 gram of copper. Try to solve this question. In next video lecture, I will give you answer of this question, student. So student, today video lecture I will conclude with the last topic, which is the very important. It is Coulomb's law in electrostat. Coulomb's law in electrostat. Okay, Coulomb's law in electrostat. Coulomb's law is applicable for point charges. Remember, between point charges. The concept of point charges will discuss later on when we'll study about the giant bodies. I don't want to just make complex this law for you. Simply try to understand the Coulomb's law is applicable for point charges. Coulomb actually find that if we are having two charges, here the two charges Q1 and Q2, right now I am telling you the magnitude of force. Later on we will discuss about the vector form of this Coulomb's law. These two charges q1 and q2 are separated by a vector distance r. So according to Coulomb, the force of attraction or repulsion, remember the force of attraction or repulsion, it is depend upon the nature of charge. If these two charges are like charges, then there will be repulsion, and dislike charges, there will be attraction. We have discussed in properties of charge. So the force of attraction or repulsion according to Coulomb, the force of this distance r, remember it is from the center of two bodies, that is center of mass or the center of two bodies. So the force of attraction or repulsion is directly proportional to the product of charges, and it is inversely proportional to the square of separation between two charges. It is the inversely proportional to the square of separation. That's why it is also called the inverse square law. So it is directly proportional to the product of charges and inversely proportional to the square of separation between two charges. You can write in your notebook as a statement also. Here I am not writing in a statement, I am telling you. Now this 2 can be considered as the equation, and combining this two equation we can write here the force of attraction or repulsion between two charges is directly proportional to the product of charges and reciprocal, that is inversely proportional to the square of separation. Compensating this proportionality constant, Coulomb find that for each pair of charge there is a fixed amount. For the product compensating, it is considered as k as a constant, proportionality constant. Now q1 q2 by r square. This k was studied later on, and it is equivalent to the 1 by 4 pi epsilon naught, whose numerical value is 9 into 10 to the power 9 Newton meter square per Coulomb square. 9 into 10 to the power 9 plus 9 Newton meter square per Coulomb square. You can see Newton, this will give you meter square divided by this Coulomb square. So Newton meter square per Coulomb square. This is the value of K. Here epsilon naught, it is epsilon, it is called epsilon, that is the epsilon, and the here naught, for the absolute value we represent here the naught. So epsilon naught, it is called absolute permittivity. Absolute permittivity. For air, or you can say the vacuum, this value is 8.85 10 to the power minus 12. I am leaving here the unit of this epsilon naught. Try to find out the unit of epsilon naught. I can help you. This epsilon naught is reciprocal to the K. If you are having the unit of K as Newton meter square per Coulomb square, then the unit of epsilon naught will be just reciprocal of this, that is the Coulomb square per Newton per meter square. So it is the 8.85 10 power minus 12. If we introduce the medium between these two charges, any medium, later on we'll study as dielectric, then the force will change. How this force will change we'll discuss in detail. But here we are having this Coulomb's law, and finally a formula for the calculation of force. It is 1 by 4 pi epsilon naught times Q1 Q2 over R square. Remember students, while solving the numerical, we use magnitude of the force by this formula, and the direction of force we'll try to understand in next video lecture by the vector rule. So this is all about today lecture number 3 students. In next lecture we'll start from this Coulomb's law, how to solve few simple questions of this Coulomb's law, and how to study this Coulomb's law in vector form, so that it would be easy for you to solve few complex questions of competition. Thank you students.